Hello friends, myself R.D. Mahajan presenting my video on complex number revision part 2. Let us solve the first problem. The sum and product of two complex numbers are real. Then those two numbers must be either real or conjugate. And therefore to prove this, let's consider two numbers. Two complex numbers Z1 and Z2. Such that the sum of the two, Z1 and Z2, Z1 plus Z2 as this a real number, suppose M, and product of that two number Z1 into Z2 another real number N, both are real. For quadratic equation we have this relation x square minus sum of the roots into x plus product of roots, that is equals to 0, and therefore substituting these two values here we get x square minus sum of the roots is M into x and plus product of root is N equal to 0. We call this equation 1. And we try to find out the roots of this equation by formula. We have x is equal to minus b, minus of minus we get plus m, plus minus root of square root of b square is m square, minus 4ac, a is 1 and c is n, divided by this term square root of m square minus 4n is called as a discriminant, and depending upon the value of the discriminant we have either real root or imaginary roots. Therefore first condition, if that value of m square is greater than 4n, if this value m square is greater than 4n, then we get two real roots, and that roots are x is equal to m plus root of m square minus 4n divided by 2, and the second one is m minus root of m square minus, therefore the first one we call as x1, m plus root of m square minus 4n divided by 2, and the second one is m minus square root of m square minus 4n divided by 2. These roots are real. Second condition, if m square is not greater than 4n, if we have m square as less than 4n, means this quantity is less than 4n, then we get two imaginary roots. We have x is equal to m plus minus. To have this negative, we take that term as root of 4n minus m square divided by 2 into I. Square root of negative term is imaginary, and therefore we have the two roots, x is equal to m plus I times square root of 4n minus m square divided by 2, and the second root is m minus I times square root of 4n minus m square by 2. Therefore here we are getting two imaginary roots. Means we get this required. For this condition we are getting two real roots, and for this another condition we are getting two imaginary roots, therefore which are conjugate of each other. Hence proved. Example number second, if argument of z plus 1 is equal to pi by 6 and argument of z minus 1 is equals to 2 pi by 3, then find the value of z, or find that complex number z. Therefore, let's consider that z as x plus iy as a complex number whose argument is given by theta, and theta is nothing but tan inverse of y by x. This is the definition for argument of z, and therefore we have two given information. The first one, argument of z plus 1 is equal to pi by 6. Substituting the value of z as x plus iy, we get argument of x plus iy plus 1, and that is equals to pi by 6. This is nothing but argument of collecting two real terms in first bracket, that is x plus 1 real term and plus iy imaginary term, and that is equals to pi by 6. This is a complex number, and argument of any complex number is tan inverse of y by x. Here y divided by x, x is x plus 1 real term or real part, and that is equals to pi by 6. Transferring tan inverse to other side, we get y upon x plus 1 is equal to tan of pi by 6, and the value of tan pi by 6 is 1 by square root of 3, root of 3. Then cross multiplying it, we get root 3 times y, that is equal to x plus 1. We call this equation 1. Means using the first information, we get the first equation in terms of x and y. Then we use the second relation. Second information is argument of z minus 1 as 2 pi divided by 3. This is nothing but argument of z is x plus iy minus 1, and that is equals to 2 pi by 3. Again, argument of real terms are x minus 1 and plus iy, and that is equals to 2 pi by 3. Again a complex number, and therefore its argument is tan inverse of y divided by x minus 1, and that is equals to 2 pi by 3. This is y upon x minus 1 is equal to, transferring this tan inverse to other side, we get tan of 2 pi by 3 is nothing but tan of pi minus pi by 3. 3 pi minus pi, we get 2 pi divided by 3. And standard result from trigonometry, tan pi minus theta is minus theta, tan theta. Therefore minus tan of pi by 3. And this is, and value of that tan pi by 3 is square root of 3. And therefore we get second equation as y is equal to minus root of 3 multiplied by x minus 1. And then solving that two equations simultaneously to obtain the values of x and y. This is the first equation, this is second equation. Then rewriting this, transferring this to left hand side, we get 1 by root of 3 into y is equal to minus x plus 1, and the second equation is root 3 into y is equal to x plus 1. Adding these two, this get cancelled, we get 1 by root 3 plus square root of 3 into y common, minus x plus x get cancelled, 1 plus 1 we get 2, and therefore it is 1 plus root 3 into root 3 we get 3 divided by square root of 3, and that is equals to y into y is equal to 2, and therefore we get y is equal to 2 divided by 1 plus 3 we get 4 into root of 3, and that value for y is 2 get cancelled, we get square root of 3 divided by 2 is the value of y. Substituting that value in this equation, we get square root of 3 into y, y is root of 3 divided by 2, and that is equals to x plus 1. This one is 3 by 2 minus 1, and that is equal to x, and therefore we get x is equal to 3 minus 2, that is 1 by 2. And y as root of 3 divided by 2. And therefore that complex number is z is equal to x plus iy. X is 1 by 2 plus I times square root of 3 divided by 2 is the required complex number or the required answer. Third example, last example from this part, to solve x raised to 6 minus I is equal to 0, means we have to find out the roots of this equation, and therefore rewriting that we get x raised to 6 is equal to I. Converting it into polar form, this one is cos pi by 2 plus I times sin pi by 2. Sin pi by 2 is 1, 1 into I we get I, cos pi by 2 is 0. Then converting this number to general polar form, it is equals to cos of 2n pi plus pi by 2 plus I times sin of 2n pi plus pi by 2. This is cos of, I can take pi common from this, we get 2n plus 1 by 2 times pi plus I times sin of 2n plus 1 by 2 times pi. Then taking power as 6, or transferring this power 6 to right hand side, therefore we get the value of x as cos of 2n plus 1 by 2 times pi plus I times sin of 2n plus 1 by 2 times pi, and this bracket raised to 1 by 6. This is cos theta plus I sin theta raised to some n. Then applying De Moivre's theorem, we get expansion of this bracket as cos of 2n plus 1 by 2 times pi by 6 and plus I times sin of 2n plus 1 by 2 times pi by 6. We call this as equation 1, where values of n changes from 0, 1, 2, 3, 4 and 5. Total 6 values. Then we determine first value for n equal to 0. We get x0, first root. Put n equal to 0, we get cos of 1 by 2 times pi by 6, means it is cos of pi by 12 plus I times sine of pi by 12. Then for n is equal to 1, we get x1, next root. 2 into 1, 2, 2 plus 1 by 2, 2 to the 4 plus 1, we get cos of 5 pi by 12 plus I sine of 5 pi by 12 as a second root. Then for n is equal to 2, we get next root x2, 2 to the 4, 4 plus 1 by 2, 4 to the 8, 8 plus 1, we get 9. Therefore, it is cos of 9 pi by 12 plus I sine of 9 pi by 12. Then for n equal to 3, we get x3, next root. 3 to the 6 plus 1 by 2. 6 to the 12, 12 plus 1, we get 13. Therefore, it is cos of 13 pi by 12 plus I times sine of 13 pi by 12. Then for n equal to 4, we get x4 as 4 to the 8, 8 plus 1 by 2, 8 to the 16 plus 1, we get 17. Therefore, cos of 17 pi by 12 plus I times sine of 17 pi by 12. And for last value of n, for n equal to 5, we get x5 as 5 to the 10 plus 1 by 2, 10 to the 20, 20 plus 1, we get 21. Therefore, it is cos of 21 pi by 12 plus I times sine of 21 pi by 12. These are the values of that equation, or the roots of that equation, or the required answer. 1, 2, 3, 4, 5, 6. 6 roots or 6 values of this given equation. The remaining problems I will discuss in the third part of revision for this complex number. If you like my video, please share it, as well as if you are not subscribed my channel yet, please subscribe it, and to receive the notification for my all new videos, you have to press the bell icon. Thank you. Thanks for watching.